Welcome to JC Connect. Yesterday we were discussing about the different tests on cement. So in that we have discussed finest tests, we have discussed soundness test and consistency test we have discussed. So now today we will uh, go for the heat of hydration. The heat of hydration is an very important test on the cement. Normally, this we will not conduct it in our lab. Actually, that facility is not there. But of course, I will give you the demo lectures of this heat of hydration of all the tests. Normally, um, when you add cement to the water, normally one type of sound it will come or it will create some of the bubbles. um, so normally these bubbles are nothing but the heat is liberating. And normally sometimes the heat is going to generate. Normally slowly the heat is going to liberate. So that is why we have two types of reactions are going to happen. Two types of reactions are there. One is exothermic reactions and one more is endothermic reactions. Exothermic reactions means it is heat is released. Endothermic reactions means it is heat is absorbed. See, normally when you add the cement into the water, I already said that you are going to create the bubbles or some type of sound it is going to create. Means there you can see that the heat is releasing. um, Means heat is released. Then how much heat is going to release? Based on this we are going to conduct. See, normally this heat of hydration is a very important characteristics in most of the tests, like your finest test and your soundness test. They may like they may contaminate the cement and they can prove that the soundness test is coming this much, fineness test is coming this much. But here, if many impurities are there, based on the accuracy of the instrument, normally we will use one very specific instrument. Normally that specific instrument will give you the correct value of heat of hydration. If any standard deviation or the error standard deviation, if you are getting more than 3 or 4, so normally what will say that it is contaminated. Up to a standard deviation of 3 is permitted in this heat of hydration. See, in that instrument, it will give the direct reading on the graph itself. With reference to that graph, we can find out that where exactly how much contamination is there in the cement. See, that is why this heat of hydration, everyone should do it if you want to check the purity of the cement. I already said that, of course, it is an exothermic reaction where the heat is going to released. This heat hydration will be found out using thermoflask. Normally we'll use the thermoflask. This thermoflask is made up of borosil silicate glass. That is company borosil, means that is the name of the company, borosil uh, glass. Then normally about 120 calories of heat is generated in the hydration of 1 gram of cement. If you see this sentence, normally what it will happen is that, means if the cement is 100% pure, then it should release 1 gram of cement, it should release 120 calories of heat. Then it is the cement is 100% pure. If even it is permitted up to the standard deviation of uh, if you are getting, for example, the calories of 115, that is permitted, that will come around the standard deviation of 3. Up to 115, if it is releasing, fine. If it is reducing less than 115, then we can classify it is contaminated. And very important thing is that um, even it should not cross 120 calories also. That is also very important. up to up to 120 to 123 it is permitted, should not exceed 120 and should not go below 120 also. Sometimes it is permitted up to 115 and 123 calories. It does not mean that if it is giving high calorie it is a good cement. Hmm? Means some standard values are there, means 1152, normally 123 is the range, but 120 is calories is an um, mm, mm, standard value for the heat of hydration. So normally temperature rises about 50 degrees centigrade is observed, and this causes the serious expansion of the body of the dam. Normally when you add this is very important in case of the construction of the dam. Maybe what kind of precautions we will take when you are constructing the dam. This is a heat of hydration is very important during the construction of the dam, because normally maybe you'll the dam wall, if you want to construct it, if you are constructing it, maybe you will calculate the volume of 1 meter cube. So when you add it, it will slowly it will expand it, because it is exothermic reaction, heat is released, bubble is going to create it. Maybe it will increase the um, in place of 1 meter cube it may increase by 1.1 meter cube. Then if it is 1.1 meter cube, if it is expanding, so that much volume of extra sand and aggregate you have to add it. So of course it is not an economical. So it is better to, when you are calculating the volume of the total concrete, so then heat of hydration has to be calculated properly. Cement has to be calculated properly, because cement play a very important role than your coarse aggregate as well as the fine aggregate. If any contamination is there, of course it is going to affect the um, mm, in your dam expansion. Of course and one more thing is that when they are constructing the dam, each and every 10 days or 15 days, the consistency of the cement has to be proved at the site itself, as well as in the laboratory itself. Nowadays they will take the heat of hydration this equipment to the dam itself, and they will carry out it. So this to avoid this heat of hydration, so of course lean mix is required. So pozzolanic activity is very important. So then normally this the mixing process they have to conduct it in place of in some of the air conditioned uh, this one only, to prevent the loss of heat of hydration. So that is the artificial cooling materials they will add it during the mixing process. So sometimes they will use some of the brine solutions they will add it. This brine solutions means sodium chloride, sometimes they will use it. Sometimes sodium chloride when they will use it, suppose if you are getting the heat of hydration more, suppose if you are getting the heat of hydration is very less, they will add the sodium hydroxide. So sodium chloride and sodium hydroxides are two very important brine solutions. So if the heat of hydration is more, if you are getting, so better to use, you have to cool it, you have to cool it using sodium chloride. So if the heat of hydration is, if you are getting less, means you have to use sodium hydroxide, NaCl as well as NaOH. These are two brine solutions. Then how they are going to conduct this test? This has to be carried out in low heat cement. That is means less quantity of cement has to be taken, and for that has to be compared with the standard value. I already said that take 1 gram of cement and check the calories, how much calories you are getting. For example, total calories of whether it is exceeding 120 calories or whether it is coming down of 120 calories. Then normally vacuum flask method we will follow it. And this is very important, adiabatic calorimeter for longer period. Normally this adiabatic calorimeter means where the pressure, constant pressure is maintained inside the flask. then only you will get the, if any variation in the pressure you are getting, you won't get the correct value in the thermoflask. And should not exceed 65 calorie per gram at 7 days, and should be less than 75 should should be less than 75 calorie per gram at 28 days. And normally, uh, initially what I said is that, per gram 120 calories, that is the initial heat of hydration. Normally if you test that cement for 7 days as well as 28 days, just check the values of this. Should not exceed 65 calories per gram in 7 days, and should not be less than 75 calories per 20, means the strength, whatever the calories it is generating, it should be in the range of 65 to 75 days based on the curing period. Normally 7 days, 14 days, 28 days you will do it for curing. In that curing also, the cement should not lose its calories, means at 7 days should not exceed 65, and uh, and should be less than 75 gram in 28 days. So this is a two typical values are very important when you are conducting this test. Then cement composition test. This cement composition is very important. Normally, um, the cement composition test, it is not so easy to find out it, because you cannot see it the composition. This heat of hydration and cement composition are normally accurate method of determination of the purity of the cement. In other type of test, you can conduct it in your regular lab, and plus or minus one or two or three set standard deviation, that is fine. But when you do the chemical composition, normally you'll get where I'm losing the quantity of cement. Normally your cement is made up of the lime. Composition is mainly lime, then silicon dioxide, then aluminum dioxide, and ferrous oxide. So normally the main highest percentage it is available as silicon dioxide. So then how we are going to conduct this test? This chemical composition test is um, very very important, because normally, and it requires 2 to 3 days to conduct it. Even if you send it sample to the laboratory, first you have to prepare that specimen of the sample, and we have one specific equipment called XRD. It is there. With the help of the XRD we are going to conduct this test. So normally it is the ratio of XRD, means X-ray diffraction, it is there, that with the help of that we are going to conduct it. And we have one more EDX, that is EDX instrument is there, capital E, capital D, capital X. EDX instrument is there. um, Energy dispersive spectroscopy. So with help of that one only we are find outing the chemical composition of the test. That is the instrumental method that are accurate. And some are titration method are there, or in your environmental lab, maybe you will find out the hardness by hardness of the water by titration method. So like that, using some of the titration methods are there to test on a cement, but we are not that they are not that much accurate method. But we will follow the this EDX method and XRD method to find out the chemical composition of the test. See, this chemical composition, can the ratio is calculated by lime, that is calcium oxide, divided by silicon dioxide plus alumina plus ferrous oxide. So it is with this ratio normally we will find out what will be the value, what value we are getting. With that value we are comparing with the standard value. Then it should not be greater than 1.02 and not less than 0.66. So this ratio should be 1.02 to 0.66. Then we can say that the chemical composition of the cement is good. We have normally we have OPC is there, ordinary Portland cement. For OPC normally we'll get it 0.88. This ratio will get it 0.88. Below you can see that that is a calcium oxide 0.72 SO2. That is calcium oxide is unhydrated lime. Hydrated lime is calcium hydroxide, that is CaOH twice. So then normally it is not pure form of lime, we are using it in our kiln process. um, that is contaminated with 1 or 2 percentage of your sulfur dioxide. So then calcium oxide, um, which is contaminated with 1% of sulfur dioxide, then we have 2.8 times molars of SiO2, 2.8 moles of SiO2. Normally that is 2.8, 1.2, 0.6, these are the moles. Maybe this mole concept I'll explain it in your next class. What is this mole concept, and how we are going to find out the molecular weight, and how we are going to find out the equivalent weights. Of course it is not required, but when you are calculating this chemical compositions test, we require that all atomic weights, molecular weight and equivalent weights are required. Of course at present what we can consider it as 2.8 moles of SiO2, 1.2 moles of aluminum oxide, zero point 0.6 times Fe2O3, means 0.65 moles of ferrous oxide. Normally up to 70% silica it will be there. Alumina, next priority will be alumina, that is around 20-25%. Then remaining it will be ferrous oxide. Then other than this also many composition it will be there, but they are neglected in this formula. So this is normally if the values in between 1.0 to 2.66, this we can call it as a line saturation factor percentage. With help of this we are find outing the purity of the chemical composition test. Of course I'll explain it why, with the help of some of the graphs, how we are going to calculate this SiO2, and what kind of graph you will get it. Maybe I'll show some of the uh, uh, tests which personally I calculate. I took the sample to the laboratory, and I have found out what will be the silica and what will be the aluminum dioxide with help of that graphs. Thank you.